In this video, we will solve for unknown voltages in a circuit containing a supernode. What is a supernode? A supernode is needed for circuit analysis when there is a voltage source present without a resistor in series. Without using a supernode, it would be difficult to perform nodal analysis because the current flowing through the branch with the voltage source is not known. You then create a supernode where the nodes on either side of the voltage source are collapsed or combined into one node as shown below. Steps for solving a supernode. First step, select a reference node, otherwise known as the ground, and can count and label the other nodes in the circuit. Using Kirchhoff's current law to write nodal equations at nodes not included in the supernode is step 2. For step 3, use Kirchhoff's current law to write a nodal equation for the nodes which become the supernode. For step 4, develop relationships based on the nodes and other observations in order to solve. Step 5, solve for unknown voltages using elimination, matrix, or other desired method of simultaneous equation solving. Some important notes. It is important to consider the direction of the voltage source when determining the voltage for relationships between nodes. In this analysis, we will assume all currents flow out of each node when solving. The circuit below, we can see there are 5 nodes, including the reference node. This may lead us to use nodal analysis. However, we will notice that the 5 voltage source does not have a resistor in series. Therefore, we will need to combine nodes 1 and 2 to make a supernode. Step 1, select the reference node, otherwise known as the ground, then count and label the other nodes in the circuit. Here, we're going to choose the bottom node as our reference node, as it has the most branches and will save us a lot more algebra down the road. The other nodes we are going to label as V1, V2, V3, and V4.
Step 2, use Kirchhoff's current law to write nodal equations at nodes not included in the supernode. There are 2 nodes not included in the supernode for the circuit. One is node 4, and we know that the voltage at this node, labeled as V4, is equal to 3 volts as the independent voltage source goes directly into this node, with the other side of the voltage source defined as 0 volts because of the ground. The other is node 3, and we want to find the voltage at this node labeled as V3. The voltages at the first and second nodes, which are part of the supernode, are labeled as V1 and V2. Using Kirchhoff's current law, which states that the sum of all currents entering and exiting a node is equal to 0, we can write an equation at the third node as we would for basic nodal analysis. So V3 minus V2 divided by 10, which comes from Ohm's law to calculate current, minus 2 amps, as the current source has the current entering node 3, which is negative by convention, is equal to 0. Going back to using nodal analysis, we write V3 minus V2 as the difference of voltages because we analyze the circuit from the perspective of standing in the node and subtract other nodal voltages from that of the node we're standing in. For the supernode, we combine nodes 1 and 2 into one node, represented with a red imaginary border as shown. We can then write a KCL equation as before, thinking of these 2 nodes as 1, with 4 branches total. Therefore, we can start out with the first branch of node 1 as V1 minus 0 divided by 5. The 0 is simply shown for reference, as the voltage of the reference node, or ground, is 0, plus the second branch, V1 minus V4 over 8. Here, we know that V4 is equal to 3 volts by intersection. Therefore, we could simply write V1 minus 3 volts. We then add the first branch of node 2 as V2 minus 0 over 5. And finally, V2 minus V3 over 10, and set this equal to 0. Here is our equation with V4 as 3 volts, so there are 3 unknown variables. Step 4, develop relationships based on nodes and other observations in order to solve. Now we have 2 equations and 3 unknowns, so we do not currently have a way to solve for V1, V2, and V3. So we have to determine relationships observed in this circuit in order to solve. Let's determine a relationship at the supernode. Here we can observe that V1 minus V2 is equal to 5 volts. We can conclude this from looking at the direction of the voltage source, where the lower voltage, V2, is subtracted from the higher voltage, V1, and is equal to the voltage of the independent voltage source, as it is connected directly to each node. This is due to Kirchhoff's voltage law, stating that the sum of all voltages in a circuit is zero. If V1 is some voltage and V2 is some other voltage, then the difference between V1 and V2 must be 5 volts because the voltage source is stated to be 5 volts. Now we have 3 equations and 3 unknowns for solving our voltages. Time to solve. We first solve our KCL equation for the non-supernode node 3. We first add 2 to both sides and multiply by 10. We can then solve for V3 so that V3 is equal to V2 plus 20. We can also solve our relationship equation in terms of V2 so that V1 is equal to V2 plus 5. Now we can take the supernode equation, which has 3 unknowns, and use substitution with our V3 and V1 expressions to solve for V2. First, we multiply our supernode equation by the least common denominator, 40, so that we get the equation 5V1 minus 15 plus 8V1 plus 8V2 plus 4V2 minus 4V3 is equal to 0. Simplifying this expression, we get 13V1 plus 12V2 minus 4V3 is equal to 15. Plugging in V3 equals V2 plus 20 and V1 equals V2 plus 5, we get 13 times V2 plus 5 plus 12 V2 minus 4 V2 plus 20 is equal to 15, which can be simplified to 21 V2 minus 15 equals 15. Solving for V2, we get that V2 is equal to 30 over 21 or 10 over 7. We can then plug our value in for V2 back into our other 2 formulas to get V1 is equal to 10 over 7 plus 5, which is equal to 45 over 7. And V3, which is equal to 10 over 7 plus 20, which is equal to 150 over 7. Therefore, we have solved for V1, V2, and V3. Now, we must remember when writing our final solutions to include units. Therefore, V2 equals 10 over 7 volts. V1 equals 45 over 7 volts. And V3 equals 150 over 7 volts. And those are the unknown voltages of this circuit.
Now to review. A supernode can be used anytime there is a voltage source without a resistor in series. Make sure to identify a reference node if it is not already given as a ground. Label all nodes carefully, as for some problems, it is not directly apparent how many nodes there are. Determine relationship in the circuit to be able to solve the problem. Finally, remember to always include units when writing your final solution. Thank you for watching our video over supernodes. We hope this has helped you understand a little bit better and will help you to do better on the first exam.